a company and they forecast that they will have 1,000 consumers and 5 report developers, and there will be no self-service. And I failed to mention that earlier, but this is kind of like saying, okay, the consumers are our viewers, the report developers are our creators, and self-service users are explorers. That's kind of a way you can look at it as well. And we can explain that for a long while because, self-service is an explorer because they have access to web authoring, and that's how they will use data sources and reports created by the developers, etc. But in this case, take it for granted that we have 1,000 viewers, 5 creators, and no explorers. That is how you would interpret this very piece of information. So that's one given. Again, we're going to just try and fit this into this main rule of 6 to 8 concurrent explorers per core. And so we need to know that first part of having 1,000 consumers and 5 creators. And then the concurrency is important too. We're going to say, okay, we think we will have stable usage throughout the day. We're a Europe-based business. We're not on other continents, and people use Tableau throughout the day is what we expect. And there's going to be a peak concurrency maybe between 7 and 10, like maybe at 9 here, and that's 5% of our users. And that percentage, so concurrency is often expressed in a percentage because you know the number of viewers and creators and explorers you have. So, as a percentage, that's how you'd express that. Because in that case, we can translate that sentence from before, remember 6 to 8 concurrent explorers per core, we can translate that into a formula and we can fill in those numbers. And that's what this would look like on the top right. So the 6 to 8, I've opted for 8 here is what I've marked at the bottom. And then the number of viewers, I will multiply by 0.75 because that's my workload compared to 1 explorer. And my 5 creators, I multiply by 2.4, which is my workload for a creator. And to that, I add my concurrency. And the result is a certain number, 4.7625. Now, what is this number? Again, we're looking at the number of processor cores. That's what we're trying to determine that we need. So in this case, this would mean that I need at least 5 cores if I round up to support this kind of traffic. So 1,000 users with a peak of 5% in the morning means I need 5 processor cores to support this. And this is how I'm going to size and scale my Tableau server. Now, you would almost never set up a 5-core machine if you know the offering for GCP or AWS or Azure. Typically, there's increments that go like 1 core, 2 core, 4 cores, 8 cores, 16, 32, etc. There's probably things you can select in between, but 5 cores doesn't really make much sense from a architectural perspective. So there's a good chance that you would go for the 8-core VM or node option in that case. I'll give you a second example of a larger deployment. Maybe this is an environment where we have a portal that already has a lot of users and we know how active they are, and it's a larger deployment. So let's look at what about 3,000 consumers and 10 report developers, still no self-service because I just left it out of the examples. And maybe there's a certain reason for a high concurrency at a very specific point of the day. Maybe here we have subscriptions being sent out, which could be Tableau subscriptions, or this could be anything that triggers a high concurrency around 15 hours in the afternoon, with 20% of the users choosing that point in time to access Tableau Server. Again, any reason for that, maybe a certain business process, whatever, but we're looking at a high concurrency here. And by the way, that 5% and 20%, estimating that concurrency is the hardest part of the whole equation. A typical Tableau Server internal deployment has around 2 to 3% concurrency. So it's really, your application that'll determine whether that's higher or more spread like it is in an internal deployment. And that's kind of an exercise that you have to do by, discussing that, talking about cases, etc. Now, our equation here, just filling in the same numbers, assuming 8 per core, would mean that we need a total of 56.85 or 57 cores. And again, we're going to just go with the offering, which is a total of 64 cores to properly support the workload here at peak time. Um, and then, 64 cores, you typically wouldn't create one VM with 64 cores and a huge amount of memory for Tableau Server. You would for some applications, but for Tableau Server, as the other two rules indicated in the first scaling slide, you'd probably split that up into 4 16-core nodes so that you can distribute the workload properly over those. And I realize I'm taking slightly more time than I expected, so we'll look at this too, but in less detail. But I want to clarify what this 4 times 16 core node thing could look like, because that's pretty abstract, right? I'm saying workload balance, and then how do you design all that? So just to give you an idea,